Hi, this is Sai Krishna. I want to explain about set theory and definitions and all the formulas in the set theory. First, we have to know about the set. What is a set? The definition of set is a set is a collection of well-defined objects, and a set is denoted by the capital letters, and inside the set there is the small letters. We have when set is represented between flower brackets, and we have many types of sets, and that is roster form and then self-builder form. Uh, this is the introduction of set. Again, I am saying that a definition, a set is a collection of objects, and it is denoted by capital letter. Elements are denoted by the lowercase. And now I am going to explain about the types of set. Empty set. If in a set there are no elements, then the set is called empty set. Now another set is singleton set. In a set there is only one element, that is called a singleton set. And finite set. Finite set in the sense of there are number of elements that are countable elements is called finite sets. Infinite sets. Then in a set there are infinite elements we cannot count, and that set is called infinite set. And equal set. Equal set in the sense, in the two sets the elements are same, but without a without no without it order, and that set is called equal set. And another set is disjoint set. In two sets there are no common elements, that is called disjoint sets. Universal set. In the universal set all the elements are present, and this is about the types of sets. Now we are going to discuss about next topic, Venn diagrams. Universal set U, and how Venn diagrams are represented. Now I am going to say about the representation of Venn diagrams. Venn diagram. Venn diagram is represented in the rectangle, and rectangle, that is universal set, and subsets are represented by the circles inside the rectangle. And what we are want to know that what is shaded, and useful useful to visual relationships among the sets. And now I am going to explain about the set operations. There are 5 set operations. One, we will discuss one everyone. Union in the sense A union B. If A and B having two elements, A and B are two sets, and we are having the elements, all the elements written in one set, then that is called union elements. You can see here example of the union elements. A equal to 1 2 3 4 and B equal to 2 3 4 5 6. A union B is 1 2 3 4 5 6, like this in two sets. Union means writing all the sets, all the elements in the set. Now another one is intersection. Elements that are common in the two sets. If we are having A set and B set, and common in the both sets is called intersection. Here you can see the example. A equal to 1 2 3 4 and B equal to 2 3 4. A intersection B equal to 2 3 4. Like this we can write the intersection of two sets. Now we are going to discuss about the difference. Difference means A minus B. Elements in A but not in B. This is known as difference. You can see example. A minus B. A equal to 1 2 3 and B equal to 3 4 5. A minus B equal to 1 and 2. Elements in A but not in B. Now we are going to see about another set operation, complement. Complement. Elements in A but in the universal. U equal to all the elements present in the universal set. A is equal to 2 comma 3. A complement equal to 1 4 5. The elements in the A and elements in the U. A complement means the elements in A does not represented in the universal set. This is about set operations. And now I am going to explain about the properties of set operations. We have many properties in the set operations. Commutative law. A union B equal to B union A. This is the law of commutative law. If A union B equal to B union A, then it is called commutative law. Associative law. A union B whole union C equal to A union whole B union C. This is associative law. And another set operation is distributive law. A intersection of B union C equal to A intersection of B union and A intersection of C. Distributive law. These all the operations are used in the problems. Idempotent law. A union A equal to A. A intersection A equal to A. This is the very easy set operation. Idempotent law. And these four properties of set operations is more important in the problems and in the topic. And now I am going to explain about the laws of sets. There are many laws of sets. First, we are going to discuss about De Morgan law. De Morgan law means, and before in the complements, we have seen only complement for the set. Now here we are going to see complement for the set operation. A union B whole complement equal to, here complement is applying for each and every element. If we apply complement for the union, and it gives the answer is intersection. Here we can see that the law is A union B whole complement is equal to A complement intersection B complement. And here we can see another example. A intersection B whole complement is equal to A complement union B. Here we can see that complement is applied to the each and every element in that. Double complement law. If A complement, whole complement is A. If we apply complement for the element set A, if we apply complement, it is A complement. If we apply A complement, whole complement, the two complement cancel each other and the result is A. Idempotent law. And it is also called as dominating law also. Identity law. So, identity law, and it is also called as domination law. A union phi equal to A. In the element A, in the set A, elements are present. Union phi. Phi in the sense no elements are present in that. That equal to A. And A intersection union. Intersection in the sense common. U is universal set. Universal set, all the elements are present if A intersection U equal to A. This is about the laws of sets. And now I am going to explain about the Cartesian product of sets. Definition of Cartesian product of sets. If two sets are present, multiplication of two sets. Here we can see the example. A equal to 1 comma 2 and B equal to x comma y. Here Cartesian in the sense of multiplication of two sets. Here we can see clearly A into B equal to, here A set 1 comma 2 and B set x comma y. Here A into B equal to 1 into x. Element in the first set and element in the first set of first element and element in the second set first element multiplication. Here we can see this is the easy Cartesian product of sets. 1 into x and 1 into y and 2 into x, 2 into y. This is about the Cartesian product of sets. Now we are going to see about the applications of set theory, where this set theory is useful and where this set theory is useful. This set theory is useful in probability and statistic topics and computer science, databases and logic gates and engineering networks and circuits. In our daily life, we can use this set theory as grouping and classifications. Here we can see some more example problems. If A equal to, here what is the problem is given. Here two sets are given and they asked about the union. We are seeing the problem. A equal to 1, 2, 3, 4 and B equal to 3, 4, 5, 6. They asked that A union B. We discussed in the set operations. This is union. If A and B are two sets are given, the sets, two sets, mixing of two sets and writing A union B. And here again they asked A intersection B. A intersection B means if two sets are present, common elements we can write A intersection B. Here A minus B, another one, difference. We all these topics we have seen in the set operations. A minus B. A minus B means the elements that are present in A but not present in B. And here we can see that B minus A. The elements which are present in B then does not present in the A. We all see one and everything we will see. A union B. Here A set is 1, 2, 3, 4 and B set is 3, 4, 5, 6. A equal to 1, 2, 3, 4, 5, 6. All the elements in the two sets are written in the union and common elements are, we can see here common elements 3 and 4 and 3 and 4 in the two sets. So A intersection B equal to 3 and 4. Now we are going to see the difference between the two sets. A minus B equal to A is 1, 2 present in A, 3, 4 that are present in B. So we should not write the B elements and we should write only A elements 1, 2 and B minus A. This is reverse of this one 5, 6. We should not write A elements and elements in the A in the B we should not write it. And again another problem verifying De Morgan's law. A equal to 1, 2, 3. B equal to 3, 4. In the universal set, all the sets are present. All the elements are present. 1, 2, 3, 4, 5. Conclusion. Set theory is foundation of mathematics. Helps in understanding in logic, probability, and all the